And last but not least, for sure, is Guillaume, who's going to talk about, okay, you're building these networks, how do you test to make sure they're working properly?
Exactly. Thank you. Hello, everyone. Thank you for joining. So let's now look at how to accelerate the FTTH rollout from a test and measurement perspective and see how we can overcome the different challenges that we typically face with the network deployment. So in terms of the challenges that are typically seen deploying FTTH networks, we see a lot of failure at the activation phase. So in fact, the customers we work with, they see up to 30% failure when they go turn up customers. So this can be because of the construction phase or maybe during the activation phase. So we'll see how to reduce this. Another element is that we see through the testing process, there's a lot of manual steps that are error prone that can lead to manual inputs, maybe problems inputting data that needs to be corrected after the fact. We see also a lack of real-time visibility on what's happening in the field when the technicians are deploying and activating customers. Another challenge that has been there for a while is the workforce turnover and the difficulty to bring them up to speed in terms of the different best practices, what to do in terms of testing, deploying fiber, activating customers. So how can we overcome this? We also see a degradation on the network between the build phase and the activation phase. So sometimes you do the build and you go there to activate. Maybe the fiber that was supposed to be there is not there. Maybe the connectivity, you have a fiber flip. Maybe you have problems that are not meant to be there. So not proper documentation or actions that were done on the build phase, bringing consequences on the activation phase. And also a long time to repair. Of course, when you see one of those problems, you want to be effective when you go dispatch a crew to fix the problem. So you want to have good visibility to reduce that mean time to repair. So I'm going to present this from a network lifecycle perspective. So when we talk about the build, we mean the first fiber layout, the dark fiber. And after that, what you do is you go out to turn up the customers, do the activation, go to the customer location, turn them up. After that, you have the operation and maintenance through the life cycle of that network once it's active. If you have tickets, troubleshooting, problems that you need to go out there and fix. And finally, the upgrades, like we're discussing today, if you go from XGS PON, for example, towards 25 gig or 50 gig PON. So throughout those phases, you have different type of challenges, and there are different approach from a test and measurement perspective to help you be more efficient in all those phases. So something that is now available, and that's at the heart of test and measurement, is cloud-hosted test management platforms. So it's now possible to connect all the field test instruments via a cloud system that can be accessed through a web interface. So with this, you can have, for example, a manager that would log, with a computer to the system, and dispatch work directly in the test instruments to all the technicians in the field. So with this, you can really impose methods of procedures to all the technicians to send them proper steps that they need to do with the right configuration at the right time with the right type of equipment. So with this, you have increased control on the quality of the work being done in the field. When those tests are done, the result can then be uploaded in the cloud so that the manager can see the progress of each team. Are they progressing as they should? Is there a team that is lagging behind versus another one? I have problems at a specific location in the network where I need to put more emphasis, more actions? So this is a real-time feedback loop. So you can control what the technicians do, and you can see exactly what they do and readjust if need be. Cloud systems like this, they can be also integrated via APIs through the existing systems used by the operators. So if you have a dispatch system, a ticketing system, this can be linked to that so that when a ticket is created, there's a task that goes directly in the test instruments that needs to be done before the ticket can be closed. You can also link this, for example, to an IMS system, an inventory management system, to make sure that the testing points are at the right location using the right parameters for the right piece of network equipment that you are testing. You can also automate all this process, so the work being done in the office from the manager, so the planning, the dispatch. You can also automate the work being done in the field, the execution from the technicians themselves, and automate the test data collection. And as a second step, once you have those elements that are automated and no more manual, you can automate the transition. So the data flow from one system to another system so that it flows from the dispatch system to the test instruments, go back up in the test management system in a seamless way so that everything is connected and you have access to all this data in real time. So this is something that we've been working with different customers across the globe, and we've seen a big impact on their OPEX to be able to be more efficient for them. We work with a US FTTH wholesale provider, and automating this test process with the test cloud system, we're able to reduce by 97% the time used by the manager to create the jobs, dispatch that, and also create the closeout packages at the end of the work. We're also, other example from a UK customer this time, we're able to work with them so that the time it took them to turn up a whole neighborhood was about 2 to 4 weeks, and we were able to reduce that to 2 to 4 days with this automated system. Another US FTTH wholesale provider, we were able, by having a real control process in the field, to reduce the activation failure rate by 75%, so big advantage for them there. Other example now with the US cable operator, by, again, automating the system, having more control on what's being done in the field, we were able to reduce by 66% the truck rolls, so the repeat jobs that they had to do due to failed activation. So the first network phase is when you do the build, so when you do the fiber construction. How could we accelerate the build while still maintaining quality of the network? Make sure that we have a good network that can support higher rate gigabits. So when we look at the regular process as it traditionally is, you have network engineering that would get the design network planning, that would put this in a file, share it with the outside plant managers, and those managers would then dispatch that to the technicians in the field. And in turn, the field technicians or contractors, they would input the test point, input the different test parameters in the instrument, connect the fiber, do the testing, and after that, extract the result, typically manually with a USB stick, or email it to a manager. The manager or the quality assurance team would then organize and store the results, audit and validate the results to make sure everything was good, everything was done properly. Do the closeout package, meaning doing the test reports, combining all the results together, and with this, using this as the as-built data. And after that, activate the customer. So that's the theory, but sometimes when you do the audit of the results, you realize something was not done properly in the field, so you need to send the technician back in the field, creating delays, extra costs. It can also happen at the activation phase. Everything was supposed to be laid out during the construction phase, but once you go to activate, you realize you have problems in the network, and again, you need to dispatch the field technicians back to fix that problem. So with the automated system that is now available, there's a lot of those steps that can be eliminated because it's all connected systems to transfer the data. So to extract and send the information from network engineering, this can all be done automatically, eliminating steps that had to be done manually in the past. The OSP manager would still send the job to the technicians, but now it can be created in batch, and it's sent automatically to the test instruments, so that a lot of the steps that needed to be done manually by the technicians are not done automatically and removed from the equation. Technician would do the test in the field, but all the data sharing result, all storing the results is now being done automatically in a proper fashion. So you control this, but you eliminate steps, gain velocity. The audit process is also automated with automated closeout package generation. So all this is saving a lot of time. So in the job creation, you can go to 8 hours to about 15 minutes. You can also make sure that all the test parameters are the right one, the naming convention is the right one, everything is done in the proper order at the right time, at the right location. So you control this, so you have less repeat tests to be done. And the closeout package, meaning the combined reports following the audit of the result, is automated and can be done in 2 minutes, what was done in 30 minutes or more in the past. And at the end of this, you also improve the quality of what's being installed, reducing the failure rate from 40% down to less than 10%. We have customers that are less than 5% now using this methodology. One example is City Fibre, a customer in UK that started in 2011 to use OTDRs to do testing. Activating a neighborhood was taking them 2 to 4 weeks. And then in 2019, they started to do workflow automation. They brought this down to 1 to 2 weeks. And continuing further in 2024, last year, they connected this test management system with APIs to their own ticketing system, to their IMS database, and were then able to reduce this to 2 to 4 days. So about 4 times faster than what they were doing in the past with a higher level of quality. So this data that they have from the build phase is now connected with the system to the operation phase and activation phase. The two systems talk to the one to the other. So whatever was planned, they make sure that when they test it in the field, that it's the right thing that they see. And if not, they can correct their planning automatically with the results that they see in the field. As far as the activation phase, we put the emphasis on enforced compliance. So you have big groups of hundreds or thousands of technicians. They each work alone. They have a big pressure to do the work rapidly. So with this automated system, you enforce that each and every one of them follows the methods of procedures. You collect the data for continuous improvement and also use the data to make sure you have an accurate as-built in your track record system. Customer in US, we work with them. They use spawn power meters. So each time they go activate a customer, it's mandatory for them to do the test at the right time. And there's no way around this process. It's linked to their ticketing system. So they need to go through those quality validation metrics before they can close out a customer activation. And the data is automatically captured so that the manager, they can analyze the data and tweak the process to improve it as they go. And with this, you can build heat maps and you see where you have activation done. Do I have problems with one team versus another? I have subcontractors that are more efficient than others? How can I make sure that I train the ones that are not as good as the other ones in real time? You can also use an optical fiber multimeter to map the last mile portion of the network to make sure you have track record of that and capture the data so that when you do an upgrade, you have the data in place to make sure, okay, can my network sustain 25 gig or 50 gig PON applications? And of course, you want to make sure that the fiber layout is good when you're going to upgrade to higher rates. Typically, it should not be reworked. So by tighter control, you can make sure that it's good from the get-go. So again, City Fibre, they have deployed Exfo Exchange through the network because it provides them with a fast, accurate picture of what's happening at any given location through this cloud-based system. So with that, they were able to enhance the decision-making. They have cost savings and maximize the ROI, enhance the customer experience, improve quality assurance, and that gives them a competitive advantage versus the other providers in their area. And with this, we can automate the operation and maintenance phase as well to reduce the time to repair because we're linked to the inventory management system. We see exactly where the problem is. We can dispatch the right time to fix that problem. We have the documentation that is used from the as-built, accessible to the technicians. So when they go out there to do a trouble ticket, they have access to this info to find the problem faster. And for network upgrades, again, we can do simulations within the system. Okay, if I change some parameters, can I go with higher rate PONs? If I was to go with a higher split ratio, can my current network sustain it? And things like this to make it more efficient through all the phases of the network. So, test and measurement, it evolved a lot through the last years. Test strategies has always played a crucial role in deploying good quality network. What's new now is that you have connected systems, connected instruments. You have test instruments with embedded cellular connectivity inside them so that you can automate the test process. You can connect the test piece to the other systems you have in your network to make sure that you don't have bad surprises. You can do faster troubleshooting, and you can be ready to upgrade the network to higher rate PONs. All right?
Superb.